growth and decay using logarithms, example 2. Irina has 5,000 euros to invest in an account that pays 5.2% per annum, interest compounded annually. Find, using logarithms, how long it will take for her investment to reach 20,000 euros. Okay, so the initial amount that Irina has, u sub 0, is 5,000 euros. Okay, so I will not write down the euro symbol, it's just 5,000. Now I want to know the number of years she has to wait until her investment attains the value of 20,000 euros. So what we know, it is compounded annually, which is said here in the problem statement, and the interest rate is 5.2% per annum. So let me denote I equals 0.052, which is 5.2% written as a decimal number, and I can suppose the formula used when compound interest is calculated, u sub n equals u sub 0 times 1 plus I, all raised to the power of n. So let me talk a little bit about this formula. N is the number of years, and at the end of each year the interest is compounded. Okay, so the original amount is u sub 0, it's 5,000 euros, and after 0 years has passed, you have this bracket raised to 0, which is just 1, so you will have the same amount as you put into your account. So u sub n will be u sub 0 when n is 0, of course. Now, after 1 year, you increase it by a factor of 1 plus I, so it will be increased by 1.052. So you multiply it by 1.052 to get the value after 1 year. Then you multiply again after another year has passed, and so on, up until the n years. So after n years you have this amount here, u sub n. So this is not a continual interest, this is the interest compounded annually, so it's pretty easy. What you need to do is to establish the value of n, the number of years Irina has to wait until her investment reaches 20,000 euros. So what I need to do is to realize that u sub n is 20,000. So this is what I want 20,000, and this is equal to 5,000, which is the initial amount, times, and now we have 1 plus I, which is 1.052 to the power of n. Okay, so you see this is an exponential equation and your unknown is n, and it's up there in the exponent. So what we can do here is to simplify it a bit. What I can do is to divide this equation by 5,000, and 20 divided by 5 is just 4, so 4 equals 1.052 to the power of n. Now to solve it we can use logarithms, so what I need is to take a logarithm, say decimal logarithm, of both sides. So I get logarithm of 4 equals logarithm of 1.052 to the power of n. If I use the power rule law for logarithms, I can get the following. Logarithm of 4 equals n times logarithm of 1.052. Okay, so this allows me to express n, so I can divide the whole equation by a logarithm in base 10 of 1.052 and get the answer. So n should be logarithm in base 10 of 4 divided by logarithm in base 10 of 1.052. So this should be it. Now let me use the calculator to approximate the result. So it's logarithm of 4, so I use the calculator and type in logarithm of 4 divided by, and again logarithm of 1.052. Close the bracket, so here it is, something like that, and I get the answer which is 27.346 or 7 approximately years. So, well, it means, what does it mean actually that we got a decimal number? So it perhaps tells us that if she waited only 27 years, there would still not be the whole sum of 20,000 euros. So what she needs to do, since the interest is compounded annually, is actually to wait for the number of years, which is 28. So she has to wait for 28 years, and the money that she will obtain after that period, the amount will be greater than 20,000. We can check it by the simple calculation. So U28, so the amount after 28 years will be 5,000 times 1.052 to the power of 28. So let me use the calculator to calculate this. So it's 5,000 times 1.052 to the power of 28. Okay, and the answer is 20,000. So she gets after that time 20,673 euros approximately. Okay, so this is the meaning of our answer. We cannot get 20,000 euros exactly after a whole number of years, but we can get approximately 20,000, and since her goal was to get 20,000, it's okay to ask for a little bit more.